Greetings, my friends. Let's go over the solutions of 4.1 and 4.2. I assigned one problem of each. So from this one, number 11, this is applications of exponential growth and so on. So let's see. I'll read the question for you. We have a candy maker, and he makes candy, because that's why he's a candy maker. And so, where is he? Where's my candy maker? Okay. The candy maker makes 500 pounds of candy per week, while his large family, large meaning because they have to eat a lot of candy, you'll see, they're going to eat at any time 10% of what he has, 1/10. They say, okay, you're making candy, 1/10 is for us. Okay. By the way, this 1/10 is something that is in English has a name for it, tithe. It was something that farmers had to produce 1/10 of their income had to go to the Lord, to the feudal Lord. So this is a very old practice that you give away 1/10. It's also, for instance, this is also perhaps used in when you give an almony or you give to charity. But that's just a little remark here. So the question is now, if he starts with 250 pounds, what is the amount of candy at any time? So Q is the amount of candy measured in pounds, and T is measured here in weeks. In pounds, okay, and T is measured in weeks. We all have to make sure that everywhere that we use numbers that they are in these same units. The units I'm not gonna pay too much attention to, but yeah. Okay, so this is the rate of change problem. We have this candy that changes, and that changes for two reasons. One is Horatius' family eating 1/10 of what he has, and the other one is because he makes it. So let's write down each. The making, of course, is going to be positive, and each time he has 500 per week. So that's where the 500T comes from, right? If he works for 4 weeks, then he has 500 times 4, 2,000, make 2,000 pounds of candy. Now his family eats it at the rate of Q over 10, 1/10 of Q. Okay, and you see that here this depends on Q, so we do get a differential equation. It's a non-homogeneous one. The step one is okay. So before we go on, let's write down also the initial condition that we can use that later. Q0 is 250. Okay, so we go to the companion equation, the homogeneous equation. That would be Q prime equals minus Q over 10. We can separate the variables, so that becomes dQ over Q. Okay, we bring that to the other side, and here we have minus 1/10 dt. I keep the 10 there, I don't know, it's easier. So if I now enter derive, so I get, this is ln Q equals minus 1/10 t plus a constant, right? Okay, we need to solve, so we exponentiate. So we get Q equals e to the minus 1/10 t plus k. E to the k, we split that off, so e to the k times e to the minus 1 t over 10, and write it just like that. And then this becomes our new constant c. So our solution, or a homogeneous solution, let me write a subscript now that we remind ourselves what this is c e to the minus t over 10. Okay? Now, that's not a solution to the actual problem. We need a particular solution, and that is done by varying the parameters. So we do, this is the formula, right? Where QH is now one of these solutions that we have there. So in this case, again, dropping the subscripts because we're going to work with this thing. It's u e to the minus t over 10. And this is the variation of parameters. Oh, this is the parameter, sorry. U is the parameter. Okay, so how do we do this? We take the derivative here, that is product rule, plus copy the first, take the derivative of the second, that is minus 1/10 from the chain rule, e to the minus t over 10. Great. And now we plug this in into the equation. So the equation was that this was equal to 500t minus q over 10, and q, don't forget, is u e to the minus 1 t over 10. Okay, now we know that this in order for this, the technique tells us that we're gonna cancel u in this case, and this happens, right? This u is now the same, this term, these two terms are the same if you look at it, and so we are left with the following equation. U prime e to the minus t over 10 equals 500t. Okay, so we find u prime is 500t e to the t over 10. Okay, bring this to the other side and becomes a positive exponent, and so we see that if I enter drive this, we get this. Now, how do we enter drive this here? Well, this is so we now have to do this integral here, and I'm going to do this at the side here. This is ILATE, integration by parts, because we have here an algebraic thing and we have an exponential. So I'm going to u and v. I hope that's okay. This in this box, u and v are something else. Outside the box, u is what I wrote down there. Okay, so u is equal to the algebraic part, so 500 t dt. I'm going to keep the 500. I don't know why, but the 500 t. Sorry, not dt, because the dt is going to go with it. This is because I put it too big. 500 t, and so dv is e to the t over 10 dt. So once you have made this choice, we have to find the du, which is 500 dt, and we have to find v, which is the antiderivative problem, that is e t10, but the antiderivative of an exponential is exponential, except we have to compensate for this factor inside here, right? We have to divide by that factor, which is 1/10. So it's not power rule, it's compensation rule, right? I've said this now many times. So we know that this is now, the integral is now equal to u times v minus integral v du. So u, that is 500t times, this actually becomes 10 t to the 10th, t 10th, right? So 500t times t e to the t to the over 10 minus v, which is this guy now, 10 e t divided by 10 du is 500 dt. Okay, so my box is a little bit too small, so I'll make a big bugger box then. So this is now 5000 t divided by 10 minus antiderivative. This is the 5000 here, and then the antiderivative of e t to the 10. We have done this one more time. It's the same thing, but again 1/10 here. So what we see is that this is 5000 t e t 10 minus 50,000, because this 1/10 comes on top of 10, right? E t divided by 10. Okay, so u is equal to 5,000. Well, et. Let's to make not have to write too many things. I'm going to factor out 5,000 and e10 in both here. So this is a t there and a minus 10 there. Okay, much easier to see what's going on. Also because we're going to have to take limits and so. So this is a particular solution. So what is the general solution now? So let's write down first what yp is, because this is u. Yp is of course, qp is u times is this one, right? We have to multiply with e t to the minus 10. So we have 5,000 e to the t divided by 10 t minus 10 times e to the minus t over 10, right? That is this part here. Oh, that's nice, they cancel out, so we found that the particular solution is actually 5,000 t minus 10. Good. So what is now our general solution? So the general solution, Qgen, right there. Remember, it is, you take the particular solution and add the general homogeneous solution, now with, that means with the coefficient, with the constant c e to the minus t over 10. Okay, and to find c, so step, if you want, I mean, no, probably this is step 4, kind of steps, this was step 3, I guess, right? Step 3 here was putting, step 4 is, we need the initial condition, if t is 0, then q was 250, so we plug this in, so get 250, t0 means that this is equals minus 50,000 plus C plus C, because C is, if I plug in 0, I get the e per factor disappears. It becomes 1. So we see that C is equal here, C is equal to minus 54,750. Right? Did I do that? No, 49,750. Okay. So our solution is, the actual solution is 5,000 t minus 10 minus 49,750 e to the minus t 10th. Looks like a bit weird formula, right? So big numbers in there. So what is going on here? So the question here now, that was the first question. This solves the question as asked. But the next question also was, what is the limit? So the limit for t going to infinity of this thing. So if he keeps doing this, is what you're curious, right? Is his family gonna eat so much candy that he's actually never gonna make enough candy, or the opposite? Well, let's see what happens if t goes to infinity, and let me do it just here on the thing, showing this term goes to 0, right? Because this is e to the minus infinity. This is 1 over e to the infinity, 1 over infinity, that's 0. So this disappears, but this part becomes infinite. So we see that the limit is actually infinite. So no, although his family is eating 1/10 of each the candy, it's only 1/10. 90% of the candy is remaining, and that's why eventually he will make that. This is why he can agree to this. He's not gonna. Eventually, he's gonna make enough candy to sell and to feed his family. Although they probably are not that hungry anymore if they have to eat this kind of amount of candy, because the amount of candy is always going to get bigger and bigger. So. Right, let's not think about too much about what's going on here. All right, so then the next question was from 4.2. That was about water going into a tank and then flowing out the tank. So that was number 14. So 4.2, number 14, and in number 14, so we had the reservoir. It had 1,200 gallons. So sometimes these tanks are limits. I don't know. I kind of sometimes ignore the limit and think of it. It's a huge thing, so it's never gonna flow over. And it says it has 40 pounds of salt, 40 pounds salt, and 600 gallons of water. Okay, that's the initial. That's how it starts. Now, we add a solution which has half a pound of salt per gallon. I don't know why you want that. It sounds to me pretty salty. At the rate. So we add to this tank at 6 gallons per minute. 6 gallons per minute. And we also drain this. And so drain the solution as being mixed at the rate of 4 gallons per minute. Now, so the units here are gallons, pounds, and minutes. Everything is in the same unit system, so we don't have to worry about this. So, okay, let's write down what happens, right? We have let's give a name. Let's QT. So QT is the amount of salt. That's what they ask, right? Yeah. So the question. Let me write the question. Oh, it says actually find the quantity QT of salt in the tank at any time t prior to overflow. We will say what that means. That prior to overflow amount of salt at the time t measured in minutes. Okay, so we have again a rate, an influx, the rate of inflow minus the rate of outflow. So let's see what happens. What is the rate of inflow? Well, we have the concentration of salt times the amount of water, the rate of water flow, inflow. Okay, the concentration of salt in that water times the rate at which that water flows in. The concentration of salt, well, it says it's a 1/2 pound salt per gallon. So it is a half per 1 gallon times the rate of flow is 6 gallons per minute. So this quantity here comes out to be 6 divided by 2 is 3. Now we have also an outflow. Let's look at the outflow. That's the same thing. The concentration of salt times the rate of water flow. This time flow out, right? But I want to say here, this is the water flow. We know what this is. This is, I didn't write it up here. Yeah, I did 4 gallons, here, 4 gallons per minute. So this is 4. But what is this thing? So the concentration of salt, so the concentration, I'll do this separately, of salt is the amount of salt divided by the amount of water. Okay, so this is the amount of water. So we need a formula for that. But that's not a difficult formula because that is just concentrates here. We have a water, you remember it starts with 600 gallons, so that's initially, and then we add, for every minute we add 6 gallons, and then we drain it every minute 4 gallons. So we add 60 minus 40, so we get, this is 600 plus 2t, that is WT, so this is Q over 600 plus 2t, and that is multiplied with 4 here, so this is Q 600 plus 2t. Okay, so let's write down our equation now. Q prime is equal to 3. This here, this rate of inflow is constant, right? Because there's the minus, and this of course depends here on the quantity, minus 4Q over 600 plus 2t. Again, let's simplify this a little bit by dividing top and bottom by 2. So 300 plus t. Okay, so step 1. Well, this is step 1 actually, right? This is step 2, say. Is setting up the differential equation. That's okay. If you would have to do this first time, you're gonna struggle to find out. But you see now several of these problems. There's gonna be another one like that in the review for the quiz. And so, okay, once you see how these things are set up, you should be able to do that. Step 2. The companion, the associated homogeneous equation, we have to solve that first. Because this is a linear equation, right? First order equation. So Q prime equals minus 2Q over 300 plus T. So that means that Q dQ over Q is equal to minus 2 dt over 300 plus T. So if I antiderive these things, we get ln of Q is equal to minus 2 ln of 300 plus T plus a constant. Don't forget the constant because we're going to need this. So we exponentiate. That is e to the ln q, that it becomes q, and that, let me write it up here, e to the k plus, and I'm going to already bring the minus 2 inside here as an exponent in the side of the ln, so that now I can split this up. This is ek times e to the ln 300 plus t to the negative 2, and therefore this is, I'm going to rename this as c, and this becomes just 300 plus t to the power negative 2. So if you want, this is c over 300 plus t squared. Okay, that's the homogeneous solution, so let me write it up. This general homogeneous solution looks like this. And now we step 3, we need a particular solution, and the particular solution is we take one of those and it's the variation of parameters, right? So in this case, this would be q is u over 300 plus t squared. Okay, now I'm gonna have to take derivatives. You see, this is, you have to jump sometimes from way of writing exponents, right? And that's why they put so much effort in it in the early days when you were taking these college algebra courses and so on, is because you constantly need to switch from one form into the other depending on what we want to do. So here we want to take derivatives, so that's why I would like to write it with negative exponents here. So this is u prime 300 plus t to the minus 2 plus u times, now the power rule is subtract 1, right? Okay, so that's the q prime, and that should be equal to, we have our formula, where was our differential equation? Here, right? Yeah. Yes, okay. So this would be, let's see, where am I? Yeah, 3 minus, let me write it up one more time, I'll copy it. 300 plus t. So this would be 3 minus 2 q. Q is u 300 plus t to the power negative 2, and then that is divided by 300 plus t. Okay, so yeah, so right, so this is equal to that. Sorry, it's a little bit, I wrote it a little bit weird. So let me box it, right? This is what I'm looking at, right? This part is q prime, and this part is this guy. Now we know that there has to be cancellations, and let's look at the term with u in. We have a minus 2. This is the power negative 3, but this is also, if you bring this up, then becomes with another negative 1, so this also becomes negative 3. So we see that these two terms are actually equal, and therefore they cancel. So what I'm left with is, let me write that, u prime is 300 plus t to the power negative 2 equals 3, right? That's the only thing left on the left-hand side. Okay, so u prime is 300 plus t square. Well, that's easy. So u is then 3. Even the 3 is even nice. Is actually 300 plus t to the power 3. And this is what I showed you sometimes, that it's easier to integrate it this way than expanding it and then integrate as if using as a polynomial. It is just a variable or a linear form of variables to a certain power. So it is really the power rule. So this is a particular solution. We don't bother about constants because we only need one. Well, the particular solution, of course, is this guy. So this is 300 plus t cubed divided by, and that was 300 here. Here is our form, right? 300 plus t squared. So actually, all powers cancel and we have one left. Okay, so the general solution, step 4, I guess I have now. The general solution is you take this particular solution, 300 plus t, and add the general homogeneous solution, plus c over 300 plus t squared. Is it squared? Yes. Okay. Now we need to find c here. The initial condition was what we do. The initial condition at we started with 600 gallons of water. So t, if t is 0. Oh no! It's not the water that we calculating. It's the salt. How much salt did we start with? 40. Be careful, right? Get the right thing here. So q is 40 here. So we get 40 equals 300 plus c over 300 plus 0. That is 300 squared. Okay, that is 90,000. Okay, so we get 40 minus, that's minus 260 equals c over 90,000. So we see that c is minus 260 times 90,000. That's a huge number. So let me just calculate this for you. 260 times 90,000. Yeah, that is 23 million. It's minus 23 million 400,000. Am I counting the right digits here? I think so. Okay. And so, right, that's our C, but let me double check here that I didn't make it. I don't want to make a silly mistake and then have to retract my video. So this was 4.2 42, number 18, right? Yeah. No, what number was this? 14, number 14. Yep, that's the correct one. Okay, so we see that the actual solution is Q equals 300 plus T plus, and now this huge C here, or minus perhaps, let's write it with the minus sign, minus 23,400,000 divided by 300 plus T squared. Okay, and I don't remember now, is this the only thing that they ask? Let me see here, let me quickly see what else was there. Yeah, what's the quantity prior to overflow? Yeah, so overflow. What does it mean that here? Well, it is a 1200 tank, right? 1200 gallon tank. So when will it overflow? Well, when the water, W, is equal to 1200. So we have a formula for this. So we have that. So overflow happens if W is 1200, and we know that W actually is given by the formula, where was W? 600 plus 2T. 600 plus 2T. So we solve for this. We see that 600 is 2T, bring the 600 to the other side, subtract from 1200. So we see that T is 300. So if T is 300 at that time, the tank will overflow. And so what is Q at that time? So Q of 300, well, that's just plugging in, 300 plus 300 is 600, minus, and then we have this 23,400 million divided by 600 squared. Now, I don't know, let's see, divide this, oh, no. How do I do this? Sorry, I don't want to use my... Right, 600 divided by 600, 65 it seems to be, so this is 600 minus 65, so this is 535. So that's the amount of salt that would be in the tank at the time of overflow. Okay. Yeah, so this number, I mean, why is this? Can I calculate this? Remember, I calculated it out, but sometimes it's better not to calculate it out. So it is, this would be, so this quantity here, that is minus 260 times 300 squared, and I'm dividing this now by 600 squared, which is 600 squared. But 600 squared is 2 times 300 squared, so it is 4 times 300 squared. So these cancel, and 260 divided by 4 is 65. Yes, so but everything is correct. Okay. All right. So that's the homework for these two things, and then you're also going to have problems that we will call. We will look at problems from mechanics next time.